Great, thanks, Ray. Welcome, everyone. My name is Steve Woolidge. I work at MapR, and I'm delighted to have comScore and SyncSort with us today. We're going to talk about some of the successes and the innovations that comScore has done, being a very early entrant to the use of Hadoop. And Mike will be giving a lot of background on comScore themselves and sort of what they're doing and the business value they provide to their clients. So we're going to kick it off really quickly and then turn things over to Mike, who's really the focus of the presentation today. So your presenters today are Mike Brown, CTO of comScore, myself, Steve, and Jorge Lopez, who will close it out for us from SyncSort. So what I'd like to do is just give a little bit of background and pass things over to Mike. Mike Brown is the Chief Technology Officer for comScore. He's been with the company since 1999 as one of the founding members, and has really been responsible for building the architecture that allows comScore to measure the internet, really, and all the interactions that people have with different content, so they can turn that into insights, information, and action for their clients. And Mike will give a lot of stats, but what's really interesting to me is that there's over 1 trillion transactions each month being measured from 172 different countries, which is equivalent to roughly 40% of all the monthly page views on the internet. So there's a lot of scale and a lot of insights that comScore is delivering. So I think it'll be interesting to get some of the insights from Mike and what they've done to really scale out their infrastructure and make it easier with the different technologies. So with that, Mike, I'll go ahead and pass the ball to you to take us into some of your secrets.
Great. So welcome, everyone. So today I'm talking about comScore's use of MapR and SyncSort. So first we're going to start off and give everyone just a little intro into who, wrong slide, the comScore story. So basically comScore's mission is to measure the digital world. And in that digital world, we're trying to understand not just how many devices are interacting with a piece of content, we're trying to understand how many people. So our mission is to be the leader in digital media analytics, to measure all forms of media, content, and advertising at scale across all platforms in real time and globally. With that, our goal is to take the information that we see that's occurring from smartphones, TVs, gaming devices, tablets, PCs, and Macs, and deduplicate that down into how many people did something. Because advertisers and our clients and marketers want to understand how many people engaged with something, because today, most people use more than one device on a daily basis. I probably use way more than one device on a daily basis. So a little bit about our company. I've been with the company since its founding in '99. We went public on the NASDAQ Stock Exchange back in 2007. We have over 2,400 clients worldwide with 1,200 plus employees. Our headquarters are in Reston, Virginia, outside Dulles Airport. And we have global coverage with measurement from 172 countries and with over 44 markets reported on a monthly basis. We also have over 32 locations spread out over 23 different countries. This slide shows how many different types of clients we have across different verticals. We're very heavily used in the media industry with Google, MSN, Yahoo, Facebook, AOL, Bloomberg, etc. as major clients. We're also very heavily used by agencies, where it's about 45 of the top 47 ad agencies use our data. But it's not just in the media space, it's also telecom and mobile, financial, retail, travel, health, and technology companies that are leveraging our data to help improve people's access to information on the web, but also to shape their marketing strategies online. So how do we do this? So big data is a very hot topic these days. comScore has 3 very unique data sources at its disposal. First, in our history, is coming from panels. We have worldwide panels on the PC and deployments of iOS and Android panels that give us real-time information at depth from what's happening on a consumer experience perspective. And that's the foundation of a lot of our products. We also then have a very large census network. That census network is happening when is data coming from when clients have put pieces of JavaScript or embedded our SDKs in their applications. So that for every interaction that occurs, it will send a data measurement to us. In addition to these two core data sources, we also have a large amount of survey work that we do, where we can go ahead and ask for people's behaviors, their attitudes about the behaviors that are occurring. With those three pieces of raw data, we have proprietary methods and models that we can take that data to deliver insights to our clients. Our insights are delivered in two different ways. One is in what we call syndicated products, and other ones are client-specific products. Media metrics and VCE are syndicated data products. And I'll talk about those in a little bit. And then there's our client-specific products, which is called digital analytics. All this is backed up by analysis and consulting that comScore helps clients shape their digital strategies. This is a screenshot of one of the core screen that comes out of Media Metrics, which is our flagship product in the audience business unit. This is showing people what's happening at the LinkedIn property in the United States in the May of 2014. So people can look at reports like this to understand the type of demographics, the person's age, their household income, what type of search terms, how the site's been trending, and what other type of categories people are going to. And then you can also understand cross-visiting. So you can see a very high site that indexes very high for cross-visiting is Glassdoor. So people obviously must be seeing something about a site, and they're going to Glassdoor to research that company. Our panel is worldwide in nature, and our approach from an engineering perspective at comScore has been to build things at global scale. This is a heat map showing where data is coming from our panel of over 2 million consumers worldwide. As you can see here, we have a very high penetration throughout the globe, and these correlate pretty well where there is population density. This is our trend. This is the history of the volume that comScore saw. So back in 2005, you were getting about 250 to 300 million records a day of data. And then by March of 2009, our data had started to explode to 1.6 billion records of data a day. And we thought this was huge. But in 2009, trying to dig out of the recession, we decided to change how we did our core business. Instead of having everything built off of a panel, which has great sets of data, we need to get better measurement because the internet had changed. People were not just using PCs, they're using many different devices, accessing it from all over the world. And that's where we implemented Census. Census is basically asking our clients to put a piece of JavaScript on their web page. And currently, over 90% of the top 100 U.S. media properties are participating in that program. And this is generating a tremendous amount of traffic. And you can see here, as this program has started, just launched at the beginning of 2009, we've hit great distribution around the globe. Again, it's not just U.S., this is worldwide in nature. And has led to this rate of data growth. So this chart here starts where the other chart had pretty much left off. So you're seeing here that in July 2009, we had a total of about 100 billion records in a month. And we've now pretty much hit a steady state of about 1.7 trillion events every single month. This growth has been quite rapid and somewhat unexpected. Given that we had this type of volume growth occurring, we had to go ahead and choose a platform that would scale with our data volume and our processing growth. And that's why we chose Hadoop and the MapR platforms. Before we talk about more in depth on the Hadoop, let's talk about comScore's use of DMX. So DMX is the product that is sold by SyncSort. comScore has been using SyncSort since the year 2000. We first bought our first 4 licenses that year in the summer, and we've used that as our go-to tool for data manipulation within the company. So anytime we have to take data and get it from one format to another, do some transformations, do a sort, et cetera. And it's been embedded in over 100 plus unique jobs every day. Our estimate right now is over 150 billion rows of data run through DMX every single day at comScore, and is a core tool in our tool chest. One of the biggest things we found that was a huge benefit to us was we have a requirement to store our raw data. The raw data is our log files. These are just written out in standard tab-delimited text files that are written out. And we used to write everything out in gzip. That gzip, we thought we were doing a good job by storing it in good old time-ordered data, and that was getting us down to 22% of the original. We found that if we did a sort on that data, we were able to reduce the size of the data down to 14% of original. And given the volume of our data, that had sizable savings to the business. Just by doing that one extra thing at the beginning on every hour of data, we're able to save 5 terabytes of data per day in disk cost. And over 460 terabytes, or almost a half a petabyte of disk space in a quarter, which is a tremendous amount of savings to the business and benefits the bottom line. So let's talk about Hadoop. So comScore, back in 2002, we realized that we needed to use more than one computer to solve our processing needs because our data volumes were getting large back then. We actually built our own distributed computing stack back in 2002. And that allowed us to dispatch jobs over multiple computers. In 2009, we noticed our data volumes were increasing at an ever-growing rate. And also Hadoop is becoming very popular in the community. And we felt that Hadoop had staying power. And it was going to be a platform that was going to be able to be leveraged by many different people. And we decided, why build our own when we can stand on the shoulders of giants? So we switched in 2009. We started building out our first Hadoop cluster. We started talking to and partnered with SyncSort on their Hadoop efforts in October of 2010. And in the fall of 2011, we completed our evaluation of MapR and switched over to MapR. The reason we chose Hadoop was this. So you can see that the amount of data, a core need for us is we have to keep at least 90 days of raw data online. That 90 days of raw data is now over 5 trillion events that have to be kept online. Where back in 2010, it was only just a little over 1 trillion. So you can see that these circles are getting bigger, and it's very hard to find one computer or one system that can handle this level of volume. So you have to use a distributed architecture. This is our high-level data flow. So data is coming to us in real time on the panel over here. And then we have data coming to us through census. Since we're in being invoked by around 90% of the top 100 media properties, that need to be very fast. So we've partnered with Akamai, and Akamai is receiving that data to us and then sending it to us. So clients get very fast response time, but then that data comes to us in 5-minute chunks. That data is pulled together on a grid of computers, and we use custom code and SyncSort to process that data and get it ready for downstream needs. This is where the 150 billion rows of data is probably sorted per day. We do something unique at comScore, or one of the unique things we do at comScore is we dual load this data. Our data is loaded both into an analytics data warehouse and also into our Hadoop environment. So for us, data exploration, product development, data QA can be done in the ADW, which is MPP SQL environment, and production and large-scale data processing is done in our MapR Hadoop environment. Now, as things go forward, most likely some things like the drill initiative or some Stinger initiatives will go ahead and allow us to run those queries all directly on the one environment. As that data is processed in the MapR Hadoop environment, and the final product is produced, it is delivered to our enterprise data warehouse for longitudinal analysis, and then we have that available within our delivery environment. So our cluster, currently we have over 400 plus nodes. The majority of these nodes are all Dell 720 XDs. Each one of these servers is pretty beefy, with 24 1.2 terabyte SAS drives, 128 gig of RAM, and 32 cores. This gives us a total of 13,800 plus total CPUs, 31.6 terabytes of total RAM, and 8.2 petabytes of disk space. And we're currently on the MapR M521 code line. Something I'm very proud about is two of our engineers, John Owens and John Lenz, were authors on this book called Hadoop Real World Solutions. So some of the features that have been implemented extremely beneficial to comScore has been partitions. MapR has a functionality in its distribution called partitions. Before I talk about partitions, I'm going to talk about the product that these partitions, how we use this. So we have a product called comScore's Validated Campaign Essentials. That comScore's Validated Campaign Essentials product, or VCE for short, is used by advertisers and marketers to understand in a more real-time basis how their ad is being delivered in the marketplace. So when someone is running an ad campaign, they receive a one-line piece of JavaScript that they put into that ad, and that JavaScript sends back information to us that we aggregate and deliver back to those advertisers on a daily basis. That data is run through our Hadoop environment and is then delivered in our interface. This product started off originally with 22 studies at the beginning of 2012. And currently we're producing, we spiked to over 4,000 studies a day now. This is the type of data you see, and the hardest measure we have to calculate is we have to calculate the rolling distribution of unique viewers, or UV as we call it. So we have to calculate how many unique viewers to an ad there were per day, and also in aggregate for that time frame. In addition to those metrics, we also provide information about non-human traffic, or what we believe is probably fraudulent, how many ads were actually viewed, were blocked, or were not in the proper geography. And then we can give a score on targeting efficiency. So talking about this product that grew exceptionally fast is when we originally started, we had just a couple million records a day to quickly going over 680 billion records in a month and over 146,000 total campaigns over 50 countries with a key space of 15 billion distinct cookies. These are all very large volumes of data, but in the end, we just need to boil it down to about 26 million rows of data to power our reports to our clients. We worked with the MapR team, and they said, and based on our analysis and discussions with the MapR engineering teams, they basically said that we all came to the conclusion that our aggregations, since we're counting distinct cookies, we couldn't make efficient use of combiners because we had large shuffles. In Hadoop, you have to move data between the different nodes to dedupe that data. So the idea was, could we implement something like partitioning? Partitioning is a concept from MPP databases where you can basically organize data based on the type of cookie. So let me demonstrate that in this diagram. So today, Hadoop primarily uses the MapReduce programming model. So what we did is we said, okay, we would launch mappers, and those maps would go ahead, each map would handle one individual chunk of characters with cookies starting with that. So the map would handle all cookies that started with A, one mapper would handle all cookies with B's, and then another map order handle cookie starting with C in this very simple example. This type of approach is something you can achieve with MapR because you have this notion of partitions. Partitions is something that originally was designed to say, I have a mixed mode of servers in my cluster, those with fast disk like SAS and those with slow disk like SATA drives. And what you could do is you could say these partitions could be put on the SATA drives. So if you're not using data very often, you put it on the slower disk. And if you're using it a lot, you put it on the fast disk. We use it in a slightly different manner where we use partitions based on the type of data. So we go through this process of splitting the data up into chunks so that we can get a much more efficient processing scenario when we produce our data. Now, every decision has risks, and we took a look at that and said, okay, well, what are the risks we have if we go down this partitioning model? We have to use a custom input format reader. It requires reading blocks, which can cause you to read over the network. But since we're using the MapR file system in partitions, it was very easy to solve that. We also found that it said that, okay, well, a failure could occur on the map side, which could resolve in long run times. But since we reduced the size of the block size to be relatively small and had a large number of volumes, we reduced that risk dramatically. The best part, though, was by doing this. So we didn't have to buy any new hardware. We didn't have to do anything too crazy. By just doing code and reorganization of the data, we took the initial work from 35 hours of runtime down to 3 hours, which was a huge win to the business and a huge opportunity to drive and support the growth of the business as it went from millions of records a day to now billions of records a day. So that's a little bit of how we use MapR and some of the special features that MapR provides in the distribution that aren't available in other distributions. Let's talk about DMX-H. So back in 2010, we started our conversations with ThinkSort because we wanted to be able to leverage our investment in ThinkSort on our Hadoop environment. And that's ended up in them producing the DMX-H product. So why did we choose DMX-H? Because we already had DMX and we wanted to go through a process. So we really looked at it, and for us, we had two core concerns. One was performance, and the other was speed of development. So for performance, DMX-H has pluggable sort in Hadoop, which allows you to increase the throughput on the existing platform. And if we can since sort is core to a lot of things that are happening in the MapReduce process, having a more efficient sort would reduce capital and reduce operational expenses. So the less servers I have to power, the lower my power bills are, the lower my data center costs are. And by increasing throughput, also allows us to deliver our data more quickly to our customers, making it more valuable to our clients. But in addition to just the pluggable sort piece, we have the ability to use DMX-H. It has a GUI to allow us to build applications very quickly. This ease of development allows us to allow more people to get access to the data, and they can use a point-and-click GUI to get at that data very quickly. So our first set of testing was on pluggable sort, and we took this and installed this on our dev cluster. We took 2 pig scripts, and we said, okay, let's take a look at group by and distinct, which is something we do a lot, and filter operations. So in the first test, our group by and distinct, that was doing count distincts, we were able to observe 20% decrease in job runtime, just off the cuff. So for us, being able to install a piece of software and get things running 20% faster is a huge improvement in the utilization of our hardware. And on a filter operation, right off the cuff, we were able to get a 5 to 10% decrease in job runtime. These are huge things that can benefit the environment quickly that makes things just run faster. So that was the one criterion. We checked that box. The next was speed of development. So for speed of development, we said, okay, let's take an existing process. So we took a process we had that we call calculating user sessions. So what user sessions are is you have a set of activity, and you want to go ahead and say, how many times is this person online in a month or a day? So you look at all their activity observed in a day, and you look for gaps of inactivity greater than 30 minutes. And then you lump all that activity together and aggregate it about statistics about that session that's observed in that day. For us, that's about 3.5 billion rows of data per day we're running through this process. We implemented it in Pig, and in that Pig process, that Pig code was about 75 lines in length and leveraged 3 Java user-defined functions, or UDFs. Took us about 25 hours to develop and runs in about 35 minutes on a daily basis. Again, not too bad. We took that, and this is the implementation of that exact same functionality in the comScore DMXH product. So here now you're going from code, and you're now having a nice visual quick diagram to show how things are executing. That process to implement that only required about 13 tasks to be implemented. We didn't have to use any Java user-defined framework, user-defined functions, because we were able to leverage functionality that was already built into DMX. Runs on the same day, the same environment. Took 12 hours to develop, which is about half of what it took to develop the Pig version. But the best part is it actually runs a whole heck of a lot faster. So it runs in 11 minutes, which is a third of the time using Pig and Java code. So with that, that's why we chose DMXH. comScore is referenced several thousand times in the press for lots of different facts. If anyone ever's in search of a piece of data and you need a quick little factoid, we aggregate all those together for free distribution. You just have to cite comScore, and that's available at the comScore data mine. And with that, I thank you for the time, and I think we'll turn it over to the others. Who gets the presentation next?
Mike, you can send it back to Steve. You just grab the ball and send it over my way. Thank you.
Thank you.
And while we're
there you go, Steve.
Thanks, Mike. That was great. So we're going to continue the conversation. We'll do a quick commercial break, if you will, a little bit of information for folks that are maybe new to Hadoop and understanding how it fits in with our architecture. So I'll walk through a little bit of that and the background on MapR, turn it over to SyncSort, and then we'll open up for questions at the end. So just as a reminder to folks, if you have some questions, please enter them in the panel. We've got a few great ones in already, and I'll Q&A at the end. So we'll go pretty quickly through this so we've got time to pick Mike's brain some more on some of the lessons that he's learned as they've really matured their deployment and done a lot. So that, at a high level, everybody talks about big data and what the volume, velocity, variety, all those types of things. The reality is that there's a lot of change in enterprise architectures, and there's a lot of systems already in place, whether they're operational, transactional systems, or analytical systems. And all of these things have production level requirements around workload management, service level agreements, being able to do backup and recovery, and really work well within the rest of the enterprise architecture. Hadoop has entered in as a core foundational piece that allows people to bring in more types of data, process it in different ways, and then feed it to other systems within their environment, which is part of what Mike just showed. And if you look at another trend, this is from a MapR customer, Indeed, which is based out of a Japanese, it's a subsidiary based out of Japan. You look at the job trends around different technologies that are showing up on the market, and there's really been a huge influx of people going into the Hadoop space. As Mike said, it has a lot of staying power, and it's becoming the backbone of a lot of operations that people are putting into their data center. And the reality is that, from a MapR perspective, we really want to focus on allowing Hadoop to meet those same levels of SLAs that you have from any other production level system, whether it's storage system or a data warehouse. So being able to meet requirements around reliability, interoperating and integrating with other systems through open standards, performance, and being able to support lots of different types of workloads, that's really the foundational piece of what we try and build into our distribution. So the analogy we like to make is that if you're going to build a skyscraper, you really need to pour the foundation first and think about the things that you're going to build on top of. So things like data protection, performance, multi-tenant environments, fundamental things down at the file system level such as volumes or partitioning, which Mike talked about, and how they are able to utilize that in being much more efficient with their operations, are all important so that you can deliver on value to the business. So at the end of the day, what we've done with the MapR distribution, which includes Apache Hadoop, is we take a lot of that innovation that is built around the ecosystem. In some cases, we lead projects like Apache Mahout or the new drill project, which is coming out. In other cases, we test all those projects within our distribution, make sure that they're rock solid and ready for production level environments. We wrap that with the management console and the data platform, which is really where we've innovated around things like availability features, performance, these multi-tenant environments, and a lot of the deep operational types of technologies that can be leveraged for disaster recovery, snapshotting, backup and recovery, et cetera, et cetera. So I won't go through all the details here, but there is a lot of innovation happening in the Hadoop ecosystem that can be leveraged by organizations. Now, you can do some types of data processing and integration workloads with scripting. People use Pig and Hive and other types of projects to do some of that, but there's off-the-shelf commercial software such as with SyncSort that really eases that with less of a code environment. So we'll turn over to Jorge in a minute to talk about that. So real quickly, who is MapR? We've been in business since 2009. We had our beta come out in 2011, as Mike talked about, and today it's cited as the top-ranked Hadoop distribution if you look at Forrester Research in a report they just published. And we've seen a lot of adoption by customers because of the things we've done around enterprise-grade performance, reliability, et cetera. And a lot of that innovation has really trickled down from the things that we've seen in the Hadoop community and leaders like Google. And we just announced last week that Google Capital has done a big investment within MapR to really take that technology and that innovation that we're developing and broaden it out globally. So just some quick background on MapR. And then what we do with SyncSort is integrate tightly with their technology to make sure we can package that up and deliver it for customers. So with that, I'll turn it over to Jorge to talk a little bit more about SyncSort specifically. And I'll just pass you the ball, Jorge.
Thanks a lot, Steve.
If I can. Actually, I'll just push it for you because I'm having an issue grabbing the ball, unless Ray can do it.
Sure, no problem. That works. Thanks, Steve, and thanks, Mike, for the great overview. So as you've seen, MapR has developed kind of a platform for big data. And this platform, the way we view it, is very similar to an operating system with highly scalable utilities and services that provide anything from high-performance processing to management, monitoring, and security. This operating system also enables other applications for data processing like SyncSort. Now, SyncSort has developed a unique ETL technology that is deeply integrated with Hadoop. We actually made a series of contributions to the open source community that allows us to seamlessly plug SyncSort software directly into Hadoop. And this way, SyncSort runs as part of your Hadoop cluster. So unlike other tools, SyncSort does not generate any code, such as Java, Pig, or HiveQL. It doesn't need to compile, and it doesn't have any tuning or code maintenance requirements. So the above diagram is just a simplified representation of how SyncSort integrates with MapR, including some of the most common use cases. We have customers using SyncSort to bring data from a large variety of sources, ranging from legacy like mainframes or relational databases to newer sources such as social media and Salesforce.com into Hadoop. They also use it to develop sophisticated Hadoop ETL jobs without the need for manually code, as Steve was pointing out, and also to sometimes accelerate existing MapReduce processes within Hadoop. And finally, to offload heavy ETL workloads from the data warehouse into Hadoop, freeing up database capacity and optimizing performance. So next, please. So, but some of you may not know who is SyncSort. So for those who don't know SyncSort, we are a leading big data company dedicated to help our customers to collect, to process, and distribute extreme data volumes. Our customers are companies like comScore, who deal with some of the largest and most sophisticated data volumes, and that's the reason they've come to us. We provide the fastest sort technology in the market and the fastest ETL engine, and we also provide the fully integrated approach to extract, transform, and load data with Hadoop. One thing I wanted to mention is, even though we have a big mainframe heritage, we also are a big player in the Hadoop space. In fact, we recently ranked as one of the top 7 contributors to Hadoop by an independent study conducted in Japan. And this is based on the lines of code we changed in 2013. And why Hadoop ETL? So many of you may not be as familiar with the term ETL, and however, it is still one of the most common use cases for Hadoop. Most organizations are using Hadoop to collect data from multiple sources. Then they process that data, typically by doing some transformation work, such as sorts, joins, aggregations, and so on. And finally, they distribute the data, loading it into a wide variety of target systems, such as data warehouses, NPP appliances, or even leaving that data in Hadoop itself. And that's exactly what ETL stands for: extract, transform, and load. This is the same process that many organizations have been doing for years in traditional data warehouse systems. Now, the challenge is, while Hadoop is a great platform for big data, it's not a complete ETL solution. And that's why we've worked with the open source community and with partners such as Mapar to develop the MXH. So why the MXH? Because it provides all the connectivity you need to extract and load data into Hadoop without writing any code. Because you can develop complex data processing flows with a simple graphical user interface in Windows and then deploy natively in Hadoop. Because its runtime engine runs natively on each node of your Hadoop cluster, resulting in even faster throughput per node. And finally, because it also integrates with leading authentication protocols such as Kerberos and LDAP to help you secure your Hadoop environment. Now, before we close, I would like to address one of the most frequent questions that I've heard from companies looking at Hadoop. What's the best way to get started with Hadoop? To answer this question, I usually like to refer to Dr. Jeffrey Moore, who's better known for his best-selling book, Crossing the Chasm. There he describes how, in order to adopt disruptive technologies, most pragmatists need to face an intractable problem. And as we saw in the webinar, data-driven organizations are facing these type of problems with big data, and they are solving them with Hadoop. We just saw how comScore moved into Hadoop to provide the best products and services to its clients. And I understand not all organizations might be as sophisticated as comScore, but the good news is, in many cases, the problems are even more obvious. In many cases, ETL workloads executing on the data warehouse are that intractable problem. So many organizations spend millions of dollars a year in database upgrades just to process growing ETL workloads. So one may wonder why use all this premium capacity to land, sort, aggregate, and join data. With Hadoop, we can just ship these workloads into this highly scalable platform. And the savings alone can justify adopting and building a Hadoop cluster. So these are just a few examples of targeted solutions to get you started with Hadoop. Data warehouse optimization, which is basically an end-to-end solution to upload heavy data integration workloads from your data warehouse into Hadoop. Mainframe offload, a complete approach to access, translate, and analyze mainframe data with Hadoop. And clickstream analysis, which is one of the most common use cases for Hadoop due to the high volumes and semi-structured nature of the data. So with that, I'm going to pass it back to you, Steve.
Okay, thanks, Jorge. So this is great. We've got about 15 minutes left for questions. So while we're teeing that up, there's a couple links here that I'll just make available for folks if they want to get started trying out Hadoop with the MapR Sandbox, sync sort, as well as there's a nice white paper that we published with an independent third party, Mike Ferguson, who's been a long time in the data warehousing and analytics space. It talks about some of the best practices for doing ETL workloads in Hadoop and how it coexists with a data warehouse. So that's also available at that link if people are interested. So presenters, thanks for joining. I'm going to tee up a couple questions here. There's a lot of stuff coming in. The first one is for Mike, and the question is, what was your biggest challenge going from relational database management technology to Hadoop from an IT and a business perspective? And I think you're using both, so you can kind of answer it how you see fit. But what are some of the trade-offs or differences? Why not use a big relational database for some of the things that you did?
Yeah, you can get, so first of all, we were actually prototyping a lot of cases in SQL on an NTP database first. We then use that as a proof point to make sure that the Hadoop implementation is done properly. The biggest thing from a development perspective, when you're taking people going from a SQL perspective to a Hadoop, is learning to process in a distributed manner. So that's the biggest issue from a tech perspective. The benefit of moving that from running it in large SQL operations to Hadoop is that you get a much better scale efficiency in terms of the amount of data you can store and the amount of concurrent processes you can run from a pricing perspective. So it's more economical for the business to work that. But as I described, we actually have all of our data in both, but it's primarily used for QA, product development, et cetera, in the SQL environment, which gives you that interactivity. And we use Hadoop in MapR's platform for its strength, which is large-scale batch processing. So think of our implementation as Hadoop is for production.
Okay, very good. And Mike, there's a couple other questions. Obviously people want to, you made the reference of standing on the shoulders of giants when referring to the Hadoop ecosystem. I think, one phrase I've heard is that it's great to have innovators that are sending postcards from the future. So from your perspective, I guess some questions, I'm not even sure if you use these, but do you have a NoSQL database in your environment? Somebody was asking about Cassandra versus HBase. Do you have any experience there that you would share in terms of that?
Yeah, so we're not a big user of Cassandra or Mongo or anything like that. We do have basically like a couch out there for storage of information, for configuration information, et cetera. But our business does not we've not found a solid use case within our environment for leveraging Mongo or Cassandra type of systems. So it's predominantly a large-scale use of flat files. Got it.
And there are some other general questions around that, so I'll answer one of these. So the question that I saw from someone is, which distributed database works best with Hadoop, Cassandra, or HBase? And I would say that if you're using Hadoop as your platform and you have huge amounts of data, the recommendation I've seen is go as far as you can with HBase, and there's a lot happening in that ecosystem environment, and HBase ships with the MapR distribution. We've done a lot of innovations there, so we do also have customers that use Cassandra. So depending on the types of workloads, you can move data between those and use different NoSQL databases, but being able to leverage one directly within the distribution is also really important. And one of the uniques about MapR is we've created an in Hadoop database called MapRDB, which is API compatible with HBase. So if you develop an application in HBase and run into performance or latency issues, you can use that on the MapRDB, and we see a lot of improvements in terms of availability and uptime and performance and throughput. So that the webcast is not about that topic, but that's also something to consider. So there's different trade-offs for each of these, and there's a lot of innovation happening in the NoSQL market in general. And again, we acknowledge customer choice and we integrate with a lot of the different technologies, whether it's Couch or Cassandra and others out there. So that's one thing to consider. So the next question I'll grab here.
One point to add to that is, and we do this all the time at comScore, is we load data between our large MPP database in Hadoop. So we push data back and forth between the two pretty easily. So for us, it's pretty easy to run a SQL query and load data directly off the MapR platform and execute. So it's not just NoSQL databases that work well with Hadoop. There's also lots of great connectors out there for multiple different database environments.
Yep. Yeah, great point. So let's switch gears a little bit. And Jorge, there's some questions around ETL, and you can share a lot of your knowledge there. So quick one is, our ETL jobs have hundreds of SQL scripts, so it's not as easy to just redevelop everything for Hadoop. So what recommendations or best practices do you have for people that have a lot of existing ETL jobs and being able to leverage that within SyncSort?
Right. So actually, one of the things that we have developed and we think it's kind of unique is an utility to help analyze the SQL scripts, because that's one of the main challenges that we have seen within our customers. So we have actually a tool that can help you basically read the SQL script and document it. Produce kind of a flow chart of the entire job, and then it gives you hints and best practices to develop the same jobs using our tool and then deploying Hadoop.
Great. And Jorge, I know we've talked before. There's a lot of history, rich history that SyncSort has around mainframe. Can you talk a little bit about that? You know, one of the questions that came in specifically was, how does SyncSort help with MIPS, and what type of support you've got for mainframe data? So if you could talk a little bit about both of those aspects of mainframe, that'd be great.
Sure. So for those who are not familiar with mainframes, MIPS is one of the ways you measure mainframe capacity, and basically you get charged for utilization in the mainframe. Every month you receive a bill based on the number of MIPS that you use. So some of our customers, what they are doing is basically some of the batch workloads that happen on the mainframe, generally sorting, aggregating, joining data on the mainframe, they move those workloads into Hadoop. These are mostly batch in nature. So what we provide is from SyncSort, from the Hadoop cluster, you can directly access the mainframe data, move it into Hadoop, and then basically translate it on the fly from EBCDIC to ASCII, read couple copybooks, etc., just to make sure you understand the data, and then do that processing on the mainframe. That's with Hadoop. In addition to that, we also have software that lives on the mainframe. It's a completely separate product that lives on the mainframe and allows you to offload some of the processing from the main CPU to the zip engines, which are kind of free for the mainframe.
Got it. And just a foundational question. You know, describe SyncSort. So someone asked, is SyncSort more of a mainframe? So I don't think we're saying that. Can you kind of talk about, at a high level, SyncSort, what it is you're delivering, you know, in conjunction with the mainframe, and how it's different?
Yeah. So in conjunction with the mainframe, what you can do is, again, as part of BMXH, when you have BMXH on your Hadoop cluster, you can directly access, translate, and move data from the mainframe into Hadoop. That doesn't require any additional install on the mainframe. So, for example, one thing is a lot of companies have SyncSort software installed on the mainframe itself. Over 50% of mainframes use SyncSort, and many people know SyncSort from the mainframe world. However, even if you don't have SyncSort installed on the mainframe, you can still access the data directly from Hadoop without installing any additional software. And you can do the translation from EBCDIC to ASCII, read complex copybooks, support expressions like redefines, of course, depending on, etc. And then one of the advantages is once you have the data on the mainframe, you can do a lot of processing inside Hadoop. You can do complex data flows that include not only mainframe data, but also data warehouse, data from the data warehouse, or data from JSON, or from other of the new formats, flat files, etc.
Very good. And so the other thing I would say is, and then we're going to shift gears a little bit and go back to more of an e-commerce focus with Mike, but the last comment I'll make on sort of the mainframe thing is a lot of companies have mainframes that are very reliable, been around for decades, and some of the questions people have is if they're looking to modernize some of those workloads with Hadoop, they want to make sure that the system is very reliable. And I think that's why I personally at MapR am really excited about the SyncSort relationship, because we've had a lot of joint customers where they've tried different Hadoop distributions, but to get that reliability that they're looking for, a lot of the innovations we've done in our platform really give you the uptime that are required to meet the SLAs of those workloads from a mainframe perspective. So that's one of the reasons why we're really excited about the SyncSort partnership. So with that, I want to switch it back. We've gotten some questions around real time and some best practices. So Mike, send us a postcard from the future. You've done this for, over a decade, dealing with internet data. To someone who's working for an e-commerce company or just doing interactive marketing and want to measure clickstream analytics at within a large organization, are there any best practices or advice that you have, things that you wish you would have known before you started down the Hadoop path about how to do things like sessionization or just best practices for collecting logs and those types of things? Anything that you would share?
Yeah, I think I would say, develop first things into smaller slices of time, like hourly chunks of data or half-hour chunks of data versus big chunks of days of data or months of data, et cetera. And then try to break your workload up into something that you're working on it a bit all the time versus waiting and batching it to run at the end of the time. So we learned something very early on before Hadoop and everything was the notion of, if you're trying to produce like a monthly report, you can wait until the end of the month and run that. That will take a long time to run because you're running a whole month of data. Or you could try to do a little bit every hour, and then you just sum up the results at the end, and that's dramatically much faster. So my big advice is try to break it up so you can do a little bit all the time. And then the second piece of advice is make sure whatever system you plan, you give yourself capacity for growth, because once people see what the environment can do, a lot more things will pile onto that, and you don't want to be in a situation where you don't have any capacity and people are upset with the platform because you don't have any latent capacity to try out projects or try new things. That's what drives adoptions of platforms within your environment.
Good advice. So, Mike, one thing you said early on was, I think it was you said that the majority of work done in Hadoop is with MapReduce. And I've gotten some questions here about how do you enable real time in Hadoop? What about new projects like Apache Spark? Has that been an area that you personally have looked at much from a comScore perspective? Things like Spark.
Yeah, I mean, we've been doing some looking at Spark and Shark, et cetera. The thing we've seen is we've been trying to find other there's clients that are out there that are running at, very large scale, a couple hundred nodes with Spark. We're not aware of that really happening out there. We're very interested more for our need, from a need perspective right now, it's more probably around a strong complex event processor around like Storm is probably where we see things going to. So you can, as one of the things I talked about doing a little bit all the time, you can leverage Storm to do streaming type of processing, which we think is a nice way to go forward from a processing model where you can break it up quite nicely. So we're aware of Spark and Shark, but we haven't seen anybody do large scale with Spark and Shark out there.
Got it. Now I'll give my 2 cents from a MapR perspective. We do have clients that are using Storm within our distribution. as well as Apache Spark. And it's very promising technology, and there are huge performance gains because a lot of the processing can be done in memory. But the most reliable processing in Hadoop today is still MapReduce. And even with Yarn and MapRV2, there's a lot of resource management performance enhancements there. So again, it's got to be choosing the right tool for the job is what we see. So there's a lot of different projects out there that can work within the Hadoop distro, and having all your data in one place gives you those economies of scale. A quick side question is people also are looking at search and how to use different technologies, whether it's Solar or other things like Elasticsearch, and those are things that we ship with our distribution, so we support today both of those different search technologies as well and have a lot of different customers doing things. So I put this slide up to talk about the different projects that are in there and address some of the questions that I saw come in around that as well. So we've got just a minute or two left here, and I'm just going to try and pick through this. There's a long list of questions here, so we'll answer these individually if we don't get to them all. Let me just say. So I think we've hit most of these. So I guess, Mike, from your perspective, any last pieces of advice more from like obstacles to avoid? You've used 2 different Hadoop distributions at this point. Is there anything that you wish you would have known or thought about, before you started taking the Hadoop journey in particular?
Yeah, I think that the biggest thing is the ability to, when you're evaluating a Hadoop distribution, look at how you move data in and out of the environment, and the ability to make that a transparent effort for enterprises. Most enterprises today don't have everything that speaks natively to HDFS. So that's a huge thing with the MapR distribution with NFS, because it's a very performant NFS implementation, and the ability to leverage different disk pools and the ability to organize your data within HDFS by leveraging partition are huge items to think about that gives you some nice growth down the road, whether that's for disaster, for DR plans or business continuity, or just efficiency in data processing. Those are some things to definitely think about. How you get your data in and out of the cluster is a big area you should spend some time thinking about.
That's good. Not always sexy, but very important. Okay, so with that, thank you so much, Mike, for sharing your time today. Really appreciate it. I know you've got a lot going on. Jorge as well, thanks for joining us today on this webinar. Just to remind folks, there are links here, and we'll be following up with more educational series like this. So thanks for joining, and have a great day.